Have a look at this circle here. The equation of this circle is given by this. And let's say you want to draw a tangent line right at this point here. You see, in order for you to draw this tangent line here, you need to know the gradient at this point here. And our old way of doing this would be to start with this equation here, rearrange it to make x a subject. So let's say we want to find out the gradient at this point here. Okay, so we would start out with our equation like this. Hang on. So we would start out with our equation like this here, and then we would rearrange it to make y the subject. So take away x from both sides, that will then give you this here, and then square root both sides, then that will give you the positive version. So remember, if I were to ask you what's the square root of 4, there are two answers. You could say the positive version and the negative version. So it's the same with this case here. So when you square root both sides, you're going to get two versions, the positive version, but because we want to find out the point up here, then we need the positive version. If let's say if you want to find out the gradient at this point here, then you would need the negative version. Okay, but because we want to find out the gradient or right here or over here, then we need the positive version. If we want to find out the gradient at this point here, then we would need the negative version. Well, here, if let's say we want to find out the gradient at this point here. Okay, let's just say at this point here. So we would start out with this equation, make y the subject, and then, well, from here you would square root both sides. Then we would be interested in the positive version. Okay, now so we want to work out dy by dx from here. From here we want to work out dy by dx. But to work out dy by dx, we're going to visualize this as a bubble to the power of a half. So rather than doing the square root, we're going to visualize it as a bubble to the power of a half. And then we would differentiate it. So here, so from here, we would need to use a chain rule. So here the chain rule at the moment, this bit here, if you want to differentiate it, if you want to do dy by dx, visualize it as this. Hang on. So from here, visualize it as y equals a bubble to the power of a half. So dy by dx would be, well, it's you using the chain rule here. So it would be a half, bubble intact, and then this bit gets minus by 1, so it'd be minus a half, and then we've got to times it with the differential of this bubble here, which will be minus 2x. Okay, so starting from here, if you want to differentiate it, dy by dx would be given by this. Okay, so now it's just a matter of tidying this up. So here you've got one block multiplying with another block, multiplying with this block here. So merge this block with this block here. That would then give you minus x times this thing here. So dy by dx is given by this here. So if you want to find out the gradient at this point here, you see at this point here, x would be 0.5. So you would put 0.5 into here. So 0.5 hang on. So this is your 0.5 here. Put 0.5 into here, and then into here as well, and then blah blah blah. That would then give you your gradient at that point. Okay, so or whether if we started right at the beginning here, if you want to find out the gradient at, let's say here, okay, so here you know you're going to need the negative version here. So you would start out with your original equation here. Take away x from both sides, and then when you're here, square root both sides. But because we want to differentiate it, let's say negative 0.5 here, then we know we're going to need the negative version. That's why so here when you square root this, you're going to get the positive version and the negative version. Because the point at which we want to find the gradient is in the negative version, then we're going to need the negative version. Okay, so now from here we want to differentiate this. So visualize this as a bubble to the power of a half. And then don't forget this is like -1. So you can visualize this whole thing here as this thing here. Okay. So now to differentiate it, so we are currently here. So now visualize it as y equals minus a bubble. So in your mind visualize it like this. Okay, and then when you differentiate it, it will be you differentiating this bubble. So it would be minus a half bubble, and then to the power of minus a half, and then you've got to times it with the differential of the bubble itself. So that will be minus 2x. So times minus 2x. So that will then give you this basically. Okay. So here differentiate it. So dy by dx equals this thing here. And if you want to find out the gradient at negative 0.5, then you would then, from here, you would tidy up to give you this. Because you've got one block here, multiplying this block, multiplying with this block here. Merge this one with this one, that would be simply bx, and then times this block. Okay. Well, if you want to find out the gradient at negative 0.5, then you would put negative 0.5 into here, and then into here, and then blah blah blah, and then that would then give you the gradient at this point here. You see, hang on, why isn't it scrolling? Wait that. Yeah. So here, if you want to find, given this here, if you want to find out the gradient here, our old method would be rearrange it to make y the subject here, and then differentiate dy by dx. You see, this method is really slow. In the next video, I will show you a quicker way of doing it. Doing it this way, splitting up so that y equals blah blah blah, it's really slow and inconvenient. In the next video, I will show you an easier way of doing it. Okay.